Okay, this is the grade 8 video from chapter 10.4 on distributive property. Distributive property. So distributive property in algebra is a real easy thing. It just basically means, for example, in A, if you have 2 bracket x plus 4 equals negative 8. All it really means is you are taking this x plus 4, and since there's a 2 outside the brackets, it means you are multiplying by what's in the brackets by 2, or you are doubling what's in the brackets. So if I was to draw it at x and a plus 4, this 2 outside the brackets means I'm going to multiply everything in the bracket by 2. I'm going to double everything. So I'm going to take my model, and what I'm really going to do is I'm going to clone it and double it. So 2 groups of x plus 4 pictorially will look like this. There's one group and there's 2 groups. So 2 groups of x plus 4 is equal to negative 8. So there's what our picture would look like. 2 groups of x plus 4 is equal to negative 8. So effectively, it is the same thing as, what this picture is showing us is the same as 2 x's, which are here and here, and plus 8, which is 4 here and 4 here, is the same thing as negative 8. So this equation and this equation mean the same thing. All right, so what we would do in a modeling situation, if we had 2 groups of x plus 4 equals negative 8, I would add negative 8 to this side, and I would add negative 8 to this side, and I would create 0 pairs here. And the next picture I would draw would be 2 x's is equal to negative 16 negatives, and therefore each x would be worth negative 8. X equals negative 8. I would solve it with a modeling by saying if 2 groups of x plus 4 equals negative 8, then each x would be worth negative 8. Now if I could substitute that back in here just to make sure my answer was correct, if I put a negative 8 in here, negative 8 plus 4 is negative 4, and 2 times negative 4 is negative 8. I know that's a lot of work there, but that's what it would be. So the answer is x equals negative 8. In the second question, we have this equation. So the first thing you have to be able to do is read it. It says 3 groups of r minus 2. So 3 groups of r minus 2 is the same value as a positive 3. So once I read it that way, I can model it with saying 3 groups of r minus 2. So there's an r minus 2, there's an r minus 2, and bring this up here. There's an r minus 2. So 3 groups of r minus 2 is equal to positive 3. So really, 3 groups of r minus 2 is the same as, obviously, 3 r's, because there's 1, 2, 3 r's, and a negative 6 equals 3. So these two equations, this one here and this one here, when I draw them, I can see both of them within this drawing. And if that was my drawing that models 3 groups of r minus 2, I'm going to add 6 to both sides. I'm going to add 6 to this side. I'm going to get rid of my constant, which was negative 6. And I'm going to have 3 r's left on this side equals, I'm lazy, I'm just going to copy it. No, I'm not even going to copy it, I'm just going to drag it down. 3 r's would equal negative 9. And if 3 r's equal negative 9, then each r, when I divide that into 3 groups, would be equal to 3, or x equals a positive 3, or r in this case, r equals positive 3. And I could check my answer by taking my r, removing it, and placing that positive 3 there instead, and see if both sides are equal. 3 minus 2 is 1, and 1 times 3 is 3, so I know that the r value or the x value is 3. That's how you would solve these equations with modeling. In the second part, the second show, we have, I'm going to do B first. We have this equation here. This is B first. We're going to start with B, then go back to A. And it says solve each equation. So now we're not going to draw it, but we know that we have 5 groups of 3 plus P. And instead of drawing 5 groups of 3 and 5 P's, and then saying, well, I have 15 in P, what we're going to do is we're going to use what we call distributive property, and we're going to expand this expression without having to draw it. And what this looks like, I'm going to put my arrows here, and I'm going to say I have 5 3's and I have 5 P's. Well, 5 3's would be 15, and 5 P's would be a positive 5P. So this equation will change when I use distributive property into something that I've seen before. This is a grade 7 equation now. 15 plus 5P equals negative 20. And once I have done this, this is called expanding. This is called expanding. So once we have that, I'm going to now just use my basic algebra sense, get rid of my constant by subtracting 15 from both sides. That'll leave me with 5P equals the sum of these two, which will be negative 35. Divide both sides by 5. Okay, so once we have that, we're going to divide both sides by 5, and we isolate for P, saying P is negative 7. Double check my answer by substituting it where the P was. If P is negative 7, then 3 plus negative 7 is negative 4, and 5 times negative 4 is negative 20. Okay, this is called solving algebra using expansion. However, there is another way we can do it. If I take this equation and I say I have 5 groups of 3 plus P equals to negative 20, what I can then do is say, well, I don't want to know what 5 groups of 3 plus P is equal. I want to know what 1 group of 3 plus P. So what I'm going to do is I'm going to divide this whole side by 5. And what that will effectively do is say, instead of having 5 groups of 3 plus P, those are going to cancel each other out. I'm going to have 1 group of 3 plus P. But since I divided the left by 5, I'm going to divide the right by 5 as well. And negative 20 divided by 5 is negative 4. So if 5 groups of 3 plus P equals negative 20, then 1 group of 3 plus P should equal negative 4. So once I've done this, I just have to do one step on both sides, which is get rid of the constant. And I've isolated the variable to become P equals negative 7. But if we look at the next one, the second show you know, which is A, and we look at that when it says this, negative 2 bracket x minus 3 equals 12. And I'm going to write it twice because I'm going to solve it 2 different ways. The first way I'm going to solve by expanding. So I'm going to draw my arrows. And this is a little confusing because if I don't have that negative sign there, this makes sense. 2 groups of x minus 3 equals negative 12. But since I do have that negative sign there, I can't really articulate it as negative 2 groups of x minus 3 because that doesn't make sense. So all I'm going to really think about is what is negative 2 times x, and that's going to be negative 2x because that's what a coefficient does. It multiplies a variable. So negative 2 times x will be negative 2x. And a negative 2 times a negative 3 is going to be a positive 6. So when I expand this using distributive property, I'm going to get this new equation, which is a grade 8 2-step equation. I'm now going to just isolate using my sense. Negative 2x equals 6. Divide by negative 2. And x will equal negative 3. So that's how we solve distributive property by expanding and then isolating using opposite operation. However, if we do it the second way, which is the easier method, if I have negative 2 groups of x minus 3 equal to 12, then dividing both sides by negative 2 will give me 1 group of x minus 3. So if negative 2 groups of x minus 3 equals 12, then 1 group of x minus 3 will equal whatever this is, which is going to be negative 6. So now I've created a much simpler equation. I will add 3 to both sides, and I will solve x equals the sum of these two, which is still negative 3. So in both cases, through expanding using these arrows of distributive property, or dividing by whatever your multiplier is, in both cases I isolate the variable to be the same. It's both x equals negative 3. So I solved it 2 completely different ways, but in both cases I have the correct answer. And that's what distributive property is all about.